Welcome, data professionals. Today we are mastering Snowflake Cortex Analyst, a revolutionary feature that transforms how business users interact with data. We will learn how to deploy a highly accurate natural language to SQL interface. Let's get started. Let's start by defining Cortex Analyst. At its core, it is a fully managed, agentic AI system designed to democratize data access. It translates natural language questions into perfectly formulated SQL queries. Basically, it allows your business users to ask questions like, "What is our top-selling product?" and get instant, accurate answers without needing to know SQL. Why should we use this instead of building it ourselves? Because building a production-grade text-to-SQL engine that balances accuracy, latency, and cost is incredibly difficult. Cortex Analyst handles all of this complexity for you under the hood. How do we use it? It takes an API-first approach. By utilizing the Cortex Analyst REST API, your engineering team can embed this capability directly into the tools your users already love, like Microsoft Teams, Slack, or custom Streamlit dashboards. Let's look at the high-level architecture in this flowchart. On the far left, the business user submits a natural language question. This request securely hits the Cortex Analyst REST API. The API routes the request to Snowflake Cortex, where state-of-the-art LLMs process the intent and generate the precise SQL. This generated SQL is then pushed down to your highly scalable Snowflake data warehouse for execution. Finally, the actual query results are returned to the user in seconds. The entire flow is secure, fully managed, and keeps your data exactly where it lives. You might be wondering, why not just connect a generic AI chatbot to my database? The problem is contextual accuracy. Generic AI models look at raw database schemas and guess. They don't know what your company considers net revenue or how to handle your specific joins. Cortex Analyst solves this using a semantic layer, which we will dive into next, to explicitly map your business rules. Secondly, using public AI tools introduces massive data privacy risks. With Cortex Analyst, your data stays entirely within Snowflake's secure boundary. Snowflake guarantees that your customer data is never used to train global models. Furthermore, it enforces native governance. Because it executes SQL inside Snowflake, it strictly adheres to your existing role-based access control policies. If a user doesn't have access to the underlying table, Cortex Analyst cannot query it for them. This comparison diagram perfectly illustrates the Cortex advantage. In the top track, the generic AI approach feeds a raw database schema to a public LLM. Without business context, this leads to hallucinations, bad joins, and severe data privacy risks. Conversely, the bottom track shows the Cortex Analyst approach. By feeding a curated semantic model into the Cortex Analyst engine, we generate highly accurate SQL. More importantly, the entire execution is governed by Snowflake RBC, transforming a risky AI experiment into a secure, enterprise-grade analytics tool. To make Cortex Analyst incredibly accurate, we must give it a brain. That brain is the semantic model. A semantic model is defined either in a lightweight YAML file stored on a stage, or as a native semantic view directly in the database. This layer abstracts your messy physical database into clean business concepts. First, we define logical tables which represent entities like customers or orders. Within these, we define dimensions for grouping data like region and facts, which are raw numbers. Crucially, we define metrics. Instead of hoping the AI knows how to calculate profit, you explicitly provide the exact formula, like sum of price minus discount. Finally, we define relationships. By explicitly telling the model which keys to use to join the orders table to the customers table, we completely eliminate the risk of the LLM generating a bad join path. Let's explore the structure of a semantic model using this class diagram. The root object is the semantic model, which contains the critical relationship mapping between tables. The model is composed of one or more logical tables. If we zoom into a logical table, we see it acts as a container for dimensions, which define our categorical slicing attributes, and synonyms and metrics, which contain our strict aggregation formulas. By building this blueprint, you translate technical database architecture into a language the AI can perfectly understand and utilize. No matter how smart an LLM is, some executive-level KPIs are so critical that they require absolute, undeniable precision. To handle this, the semantic model includes the Verified Query Repository, or VQR. The VQR is a curated list of plain English questions paired with the exact, human-approved SQL required to answer them. When a user asks a question, Cortex Analyst first checks the VQR using semantic similarity. If the user's question closely matches an entry, the AI skips generating SQL from scratch and instead leverages your verified SQL template. This builds immense trust with your stakeholders. Furthermore, you can leverage the VQR to enhance user experience. By setting the use as onboarding question flag to true, Cortex Analyst will surface these verified queries as clickable suggestions in your chat application, immediately showing new users exactly what the system is capable of answering. This flow diagram demonstrates the intelligent routing mechanism of the verified query repository. When the user's natural language query arrives, the system hits a decision node. Does this match an entry in the VQR? If the semantic similarity is high, we take the yes path, retrieving the rock-solid verified SQL template. If it is a novel, ad hoc question, we take the no path, falling back to the LLM to generate new SQL, using the rules in the semantic model. Both paths safely execute the query in Snowflake, giving you a perfect balance between rigid accuracy and flexible exploration. True data exploration is an iterative conversation. A user might ask, "What is the revenue for Asia?" and then immediately follow up with, "What about North America?" A basic text-to-SQL engine would fail here because the second question lacks the word revenue. Cortex Analyst solves this gracefully by natively supporting multi-turn conversations. To do this, your application passes an array containing the chronological conversation history using user and analyst rolls in the REST API payload. Under the hood, Cortex Analyst uses a specialized LLM summarization agent. This agent reads the history and rewrites the fragmented follow-up into a fully resolved question, like, "What is the revenue for North America?" This ensures the downstream SQL engine remains highly accurate. However, as architects, be aware that LLMs are stateless. Passing the full history on every turn increases the number of tokens processed, which marginally increases the compute cost per round. Let's trace a multi-turn interaction in this sequence diagram. The user asks a vague follow-up, "What about NA?" The application bundles this prompt with the previous chat history and sends it to the summarization agent. Instead of trying to write SQL immediately, this agent acts as a translator, rewriting the intent into a standalone question, "Revenue in NA." This perfectly resolved question is then handed to the core SQL engine, which easily generates the context-aware SQL. This multi-agent workflow protects the system from context collapse and ensures highly reliable answers. A common point of failure in text-to-SQL generation is handling string literals in where clauses. If a user asks for sales of iced tea, but your database literally stores the product as iced tea, a standard SQL generation will return 0 rows. To fix this, Cortex Analyst can integrate directly with Cortex Search services. Before the LLM writes the SQL, it performs a fuzzy semantic search against the high cardinality text columns in your database. It discovers that iced tea actually means iced tea and injects that perfect literal into the prompt. The resulting SQL executes flawlessly. Additionally, for further control, you can use the custom instructions field directly in your semantic model. This allows you to write plain English directives like always round currency to 2 decimal points or default to the last 12 months if no date is specified, ensuring the generated SQL perfectly matches your corporate reporting standards. This flowchart highlights the literal search integration. The user asks for sales for iced tea. The Cortex Analyst engine pauses and executes Step 1, a fuzzy search against the Cortex Search service. Step 2 returns the exact database literal iced tea. In Step 3, the engine applies any global formatting rules defined in your custom instructions. Finally, equipped with the exact string literal and the formatting rules, it generates a bulletproof SQL query containing where product equals iced tea. This dramatically reduces user frustration with zero-result queries. Let's see this in a highly valuable, real-time use case. Imagine a global VP of sales is in a board meeting and needs instant insights into regional revenue drops. Normally, they would submit a BI ticket and wait days. Instead, your team has deployed a custom Streamlit dashboard powered by the Cortex Analyst REST API. Behind the scenes, you've built a robust semantic model that maps the word revenue to a specific calculation and explicitly defines the joins between the orders and regions tables. The VP simply types, "Show month-over-month revenue growth in Asia." Cortex Analyst understands the business terms, recognizes the need for time series comparison, and instantly generates a highly complex SQL query using window functions. The chart renders in seconds. You have empowered executive leadership with self-serve analytics that achieve over 90% accuracy on real-world tasks, completely eliminating decision latency. Let's track this interaction on our sequence diagram. The VP of Sales initiates the request in the Streamlit app. The app immediately sends the natural language prompt, along with the reference to the semantic model, to the Cortex Analyst API. The API engine maps the business terms, constructs the complex window function SQL, and pushes it down to the Snowflake compute layer. The heavy lifting is done in the data warehouse, which returns the aggregated dataset back to the UI. The UI renders the visual chart for the VP. A massive analytical workload, solved conversationally in seconds. As we conclude, let's cover operations and cost management. Cortex Analyst is built using Snowflake AI compute credits, specifically at a rate of 67 credits per 1,000 messages. To keep a close eye on your budget, administrators can query the Cortex Analyst usage history view, which provides detailed telemetry on usage. Furthermore, Cortex Analyst logs user interactions to a dedicated event table. This is a goldmine for refinement. By reviewing what users are actually asking, you can continuously improve your semantic model and add highly requested metrics to your verified query repository. Finally, remember security. End users must be granted the Snowflake.Cortex user database role to invoke the LLM, alongside standard access to your tables. Thank you for joining this training. Please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final flowchart illustrates the continuous improvement lifecycle. User interactions flow into Cortex Analyst, which outputs two distinct telemetry streams. Usage metrics flow into the Cortex Analyst usage history view, allowing the admin to monitor billing. Simultaneously, event logging captures the actual natural language prompts into a Snowflake event table, empowering the admin to refine the semantic model and VQR. Combining strict cost control with continuous AI refinement results in a highly optimized production deployment. See you at quicktechie.com.